The next method to obtain the solution of equation is Euler's modified method or modified Euler's method. So it is depend on the Euler's method again. So first find y1 by using the same formula that is used in Euler's method. That is y1 is what? Just say y1 instead of y1 0. And what is it? y1 0 is y naught plus h f of x naught y naught. This is the formula used in the Euler's method to denote y1. So here is just denote y1 by y1 0. So this is the change only. And then use this formula to obtain y1, y2, y3, y4. So what is that? This y1 0 is not final at this place. So how we can find y1? So we find y1 1, then y1 2, y1 3 by using this formula. So what is y1 1? Is y naught plus h by 2, similar to this, y naught plus h by 2, f of x naught y naught plus f of x1 y1 0. So what are x1 and y1? So the value at x equal to x1. So then y1 2, find y1 2 by using this formula, y1 3, just replace 0, y1 0 by y1 1, then y1 2. In this way, find these y1 0, y1 1, y1 2 up to significant decimal points or significant errors. That is up to desired accuracy. That is, if the two answers are matched up to 0.2 decimal places or 3 decimal places, then stop to find these y1 values of y1. And the final value of y1 is what? The final value obtained in this process. So in this way, we finalize y1. Similarly, finalize y2, y3 by using these formulas. So we'll see the example of modified Euler's method. Determine the value of y when x is 0.1 by Euler's modified method. Given y0 is 1 and y dash means dy by dx is x square plus y. So similarly to the Euler's method, this y dash means f of xy is x square plus y. F of xy is what? F of xy is x square plus y. And now we have to find the y at we are given y0 is 1, means x0 is 0 and y0 is 1. x0 is 0 and y0 is 1. That is, the interval is 0 to 1. We have to find the value at 0.1. So direct find the value at 0.1 or find first at 0.05 and then find at the 0.1 by dividing this interval 0 to 0.1 by in two parts. That is, divide this interval. That is, take h as 0.1 minus 0 divided by 2. That is 0.05. So take h as 0.05. We take see in the first interval. That is, we divide. We have to find the value. We are given the value at 0, value of y at 0, and we have to find the value of y at 0.1. So 0 to 0.1, we find the values of y, the value of y at 0.1 by dividing the interval or without dividing the interval. Here we divide the interval. There is no instruction in the problem that divide the interval or find without dividing interval. So directly we can find the value at 0.1, value of y at 0.1, or divide the interval, this 0.1, in two parts, 3 parts. Here we divide the interval in 2 parts. That is, length of each interval is what? H is what? 0.1 minus 0 divided by 2, that is 0.05. Okay, and x naught means the starting point is 0, and the value of y naught is 1, this one, and then that we divide this interval in 2 parts. So first interval is 0 to 0.05, and the second is 0.05 to 0.1. Okay, now in the interval 0 to 0.05, we have this, that x naught, y naught, and h is this, and f of x naught, y naught. This is f of xy, x square plus y is f of xy. So f of x naught, y naught means substitute x as a 0 and y naught as a y naught means 1, and so we have the value 1, f of x naught, y naught, and then we will find this y1 0 using Euler's formula. This is the same formula y1, but just to say y1 0, y1 raised to 0. So it is what? Y0 plus h f of x naught y. And that is what is y naught? Y naught is 1. And h is what? 0.5, and into f of x naught y naught is 1. And this is the y1 0, that is 1.05. This is not actually y1. This is y1 in the Euler's method, but here it is y1 0. So this is the just check. So up to this, the problem is same to Euler's method. So up to this, just say y1, replace y1 by y1 0, y1 raised to 0. Then we will find y1 1, y1 2, y1 3 in this Euler's modified method. So how we can find y1 1? This is the formula: y naught plus h by 2 f of x naught y naught plus f of x1 y1 0. So first find f of x1 y1 0. So what is the value of f of x1 y1 0? X1 is now x is 0. X is 0. So x1 is 0.05. So x1 is 0.05. The value of x. Then f of x1 y1 0 is what? By using this formula, f of xy is equal to x square plus y. Substitute x as x1, means 0.05 square, plus y1 as y1 0 as this 1.05. And then we have this answer. So this is f of x1 y1 0. And then write Euler's modified formula. So y1 1 is what? By Euler's modified formula, y1 1, that is the value at 0.05. This is the value at 0.05, but by using Euler's method. This is Euler's modified method. Then y1 1 is y0 plus h by 2 f of x naught y naught plus f of x1 y1 0. And then substitute y naught, h is 0.05 divided by 2. And f of x naught y naught is 1. And then f of x1 y1 is this. And then we have this answer. So this is y1 1. Then find y1 2. So what is the formula for y1 2? Is y naught plus h by 2 f of x naught y naught, same to this, plus f of x1 y1 1, just write in the place of 0 1. And then find f of x1 y1. So this is y1. So f of x1 y1 is what? F of xy is this, x square plus y. So f of x1 y1 is x1 square. X1 square means 0.05 square, plus y1 1 is this. So this is, and then by using formula we have this answer, y1 2. So in this way we can also find y1 3, y1 4, y1 5. But if you observe y1 1 and y1 2, then the answers are correct up to 4 decimal places. And so finalize this y1 as 1.0513. That y1, take y1 as 1.0513. Otherwise, if this the difference of these two successive values of y1 is larger, then again find y1 3, y1 4. So what is y1 3? If you have to find y1 3, then what is y1 3? Y naught plus h by 2 f of x naught y naught plus f of x1 y1 2. Just write here 2. And in this way, we finalize this y1. So we are given y naught, and then we have the y1. Y1 means what? This is the value of y1 is what? The value of y at x is equal to 0.05. Then take the next interval, 0.05 to 0.01. And now x1 is what? 0.05. y1 is 1.0513. This y1, last value of y1. And then h is 0.05. Then f of x1 y1 is what? Of x1 y1 is x1 square plus y1. That is by using this formula. F of xy is equal to x square plus y. And then we have this f of x1 y1. And then by Euler's method, y2, just find y2. What is the formula by Euler's theorem for y2? y2 is y1 plus h f of x1 y1. Just write y2 0. Instead of y2, write y2 raised to bracket 0. Okay. And then y1, substitute y1, and eh value of eh and f of x1 y1 is this, and we have this. But this is not final y2. In the Euler's method, it is final y2. But we can find y2, final y2. Then find y2 1, y2 2. So what is the formula for y2 1? Is y1 plus h by 2 f of x1 y1 plus f of x2 y2 raised to 0. So instead of this y2 1 is what? y1 plus h by 2 f of x1 y1 plus f of x2 y2 0. So this is the formula to obtain the values of y1, 1, y1, 2, y2, 2, y2, 3. Substitute I as a 0, we get y1, values of y1. I substitute I as a 1. So y2 is what? Y2 1. Substitute n as 0. So y2 1 is what? Y1 plus h by 2 f of x1 y1 plus f of x1 x2 y2 raised to 0. Okay. So write y1 1. Then y1 2 is what? Just write here 1. Okay. And then substitute all the values of y naught h 0.05 by 2 f of x naught y naught f of x1 y1, and then we have this answer. Similarly, we find y1 2. So y naught plus h by 2 f of x naught y naught f of x1 y1 1, and then we have this value f of x1 y1 1 is what? X1 square, that is 0.05 square. Y1 is this. So this substitute, and then we observe these two answers are correct up to 4 decimal places, and so finalize this is as a y1. This is as a y1, and this is the value of what? The value of here is okay, y1 1. We have to find the y1 2. So what is y1 2? So x1 is this, y1 is this, and h is 0.05, and then f of x1 y1 is this, and then by Euler's method y2 0 is what? Y1 plus f of x1 y1, we have this value y2 0, and then y2 1. Y2 1 is what? Y1 plus h by 2 f of x1 y1 plus f of x2 y2 0. Then what is y2 2? It is f of x2 y2 1. Then what is y2 3? Then it is f of x2 y2 raised to 2 in this way. So substitute value of y1. Y1 is what? Y1 is this value. This value is y1 at this place. Then h is 0.05 by 2. F of x1 y1 is what? F of x1 y1 is this. Then f of x2 y2 0 is this. F of x2 y2 0 is this. And we have this answer. Then we will find the y2 2 by using this formula. So y2 x2 f of x2 y2 1, substitute here value 1.1154, and then we have this answer. And if you observe, these two answers are correct up to 3 decimal places. So finalize this, or otherwise find y2 3. What is y2 3? y1 plus h by 2 f of x1 y1 plus f of x2 y2 2. Use this value, but no need of to find the values. If the values are correct up to 2 decimal places, then finalize that values. So y2 2 is y2, then this is the value of y2, and this is the value of what? Y at 0.1. It is the value of y at 0.1. So we have to find the value of y at 0.1. Determine the value of y when x is 0.1. So this is the final answer. So the value at 0 is given, and we have to find the value at 0.1. We divide the interval in 2 parts, and then first find we have the value of y1 1, and then y1, and then we have the value of y2. So what is the value of y2? Y2 is this. So the value of y at x equal to 0.1 is this, 1.1055. So the change in the Euler's method and Euler's modified method is what? Just find the y naught, y1 by using same method, Euler's method, and then finalize y1 by using finding y1 1, y1 2. That is this. Up to this problem is same. First find y1, just say y1 0, and then finalize y1 by finding y1 1, y1 2, and then final y1. Then find a y2 0, y2 by using same Euler's method. Just say it is y2 0. This is y2. Actually, this is y2 in Euler's method. So solve this same problem by Euler's method. Then we will see the change in the Euler's method and Euler's modified method. Just these steps are increased in the Euler's modified method. And up to this again, y2 0 is the same. Y2 is the same. Just say y2 0, and then find y2 1, y2 2. So these are the more steps in the Euler's modified method. Otherwise, it is similar to Euler's method. So I can divide by dx is 1 minus y, and y0 is 0. That is x0 is 0, y0 is 0. and find y at point 2 using Euler's modified method. Take h as 0.1. That is, the value at 0 is given, and we have to find the value at 0.1 by dividing the interval in two parts actually, because h is 0.1 means find value at 0.1 first, then find value at 0.2. That is, divide the interval 0 to 0.2, 0 to 0.2 in two parts. Okay, that is, take h as 0.1. And then x naught is 0, y naught is 0. From this, y0 is 0 means y 0 at x is equal to 0. So x naught is 0, y naught is 0. And then by Euler's method, y1 0. Actually, it is in Euler's method, it is y1. Here write y1 0, y0 plus h f of x naught, y naught. Then substitute the values. We have this value. Then find f of x1, y1 0. And then Euler's modified method, y1 1. So this is y1 0, then y1 1 is what? Y naught plus h by 2 f of x naught, y naught plus f of x1, y1 0. Then find y1 1, y1 2, y1 3. So y1 1 is this by substituting the values. F of x1, y1 0 is this, because f of xy is what? F of xy is 1 minus y. So f of xy is 1 minus y. F of x1, y1 0 is what? X1 means x1 means the 0.1. So write here 0.1, 1 minus y. So 1 minus value of y1 0 is 0.1. So 1 minus 0.1 is 0.9. Then y1 1 is this. Then y1 2 is this. And if you observe these two answers, then these are correct up to 1 decimal places. So these answers, this is the answer 0.905. So these two answers are correct up to 2 decimal places, 1 decimal places. And so final y1 3, then y1 4, or directly use this as a y1. So y1 is what? This value, last value of y1. That is y1 2 is a y1 now 0.9525. Then the next interval, in the next interval 0.1 to 0.2. The first interval is 0 to 0.1, then 0.1 to 0.2. And then x1 is 0.1 now. Y1 is this, that value of this y1. That is this is x1, y1, and h is 0.1. Then Euler's formula is what? Y2. Actually, y2 is y1 plus h f of x1, y1. Just write y2 0 and then substitute values. And then find y2 1. What is y2 1? Y2 1 is y1 plus h by 2 f of x1, y1 plus f of x2, y2 0. So find first f of x2, y2 0. So f of x2, y2 0 is 1 minus y2 0. That is this. And then y2 0 is what? Y2 0 is this value, 0.1875. And then we have this answer. Substitute the values. We get y2 1 is this. Then if you observe these two answers, y2 0 and y2 1, then correct up to 2 decimal places. So finalize this as a y2. And this is the value of y at 0.2. Okay. So final answer is what? 0.1857. Similar problem. dy by dx is x square plus y. y0 is 1. And determine y at 0.2 and 0.04. 0.02 and 0.04. So first consider the interval 0 to 0.02, or divide the interval 0 to 0.02 by in two parts. That is, first take the interval 0 to 0.01, then 0 to 0.02, then 0 to 0.03, and then 0 to 0.04. So we'll find the values of. So first we have to find the value at 0.02 by dividing the interval 0 to 0.02 in two parts. So first is what? H is what? 0.01, and then x naught is 0, y naught is 1, and then f of x naught, y naught is this, and then y1 0 is y naught plus h f of x naught, y naught. Substitute the values, and we get the answer. Then y1 0, this is, then y1 1 is what? Y naught plus h by 2 f of x naught, y naught plus f of x1, y1 0. This is by Euler's modified method. Here is Euler's method. So we have this answer, and these two answers are correct up to 4 decimal places, and therefore we finalize this as a y1. This 1.01000 is y1. And then y2. How we can find y2? y2, that is the value at point not 2. By taking interval again, point not 1 to point not 2, x1, y1 are these, and h is this. And then f of x1, y1 is this. And then y2, 0. That is y actually y2, y1 plus h f of x1, y1. And then we have this. Then y2, 1 is this, y1 plus h by 2, f of x1, y1 plus f of x2, y2, 0. Okay. So just find y1, y2, y3 by using the same method. So if you have to find the next value at a point not 4, then find y3 by same method. This is for homework. That is find y3. How we can find y3? Y3 means the value by taking the interval 0, 0.2, like similar to this, point not 2 to point not 3. Take the interval point not 2 to point not 3 and find y3. Find y3 similar to y2. Here is we have y2. Then find y3 by taking interval point not 2 to point not 3, and then taking the interval point not 3 to point not 4, find y4, and that is the value of y at point not 4. Same problem. Here is the dy by dx. Shift this minus root xy to right side. So this is the fxy 2 plus root xy, and what is given? The value of y2 in steps of 0.5 using Euler's modified. Y1 is 1, means x naught is 1, y naught is 1, and we have to find the value at 2. We have to find the value at 2, and the value at 1 is given. Then we take step of 0.5, means first find the value of y at 1.5 and then at 2. So Euler's method. By using Euler's method, what is the formula? This is the formula, general formula. Then find y1, 0. First y naught plus h of f of x naught, y naught. This is the same formula, Euler's formula actually. And then y1, 0 is this. And then y1, 1 is what? Y naught plus h by 2, f of x naught, y naught plus f of x1, y1. By using this, substituting en as 0, 1, 2, 3, we have these formulas. So y1, 2, y1, 3. And if we observe y1, 2 and y1, 3, answer correct up to 1 decimal places. Finalize this. Final answer of y1, 3 as y1. And this is the value of y at 1.5. This is the value of y at 1.5. Y at 1.5. Then take the next interval, 1.5 to 2. And find y2, 1, first y2, 0. Y2, 0 is what? Y1 plus h f of x1, y1. Y1 is what? Y1 is this. And x1 is what? X1 is 1.5. X1 is 1.5. X naught is 1. X naught is 1. Then 1.5 because h is 0.5. H is 0.5. So x1 is 1.5. And x2 is 2. So we use this formula. The y2, 0 is y1 plus h f of x1, y1. So substitute the values. We have the answer. Then y2, 1 is y1 plus h by 2. F of x1, y1 plus f of x2, y2, 0. And substitute the values. We have this. These answers are correct up to 2 decimal places. And so finalize. This is the value of y at y2, 3 is the final value of y2. And this is y2, means this is the value of y at 2, not point, at value at 2. So by dividing the interval 1 to 2 in 2 parts, that is first find the value at 1.5. This value y1 is value at 1.5, and then y2, that is the value at 2, is 5.0622. So similar problem here. Here is the y0 is 1, means x0 is 0 and y0 is 1, and determine y at 0.2. Directly determined at a y at 0.2, or divide the interval in 2 parts. That is, first find the value at 0.01, then at 0.02, then at 0.03, and then at 0.04. So same problem. Here is the value. This is the problem. So same problem. Here the answer is at first find at y1. Y1 means the value at 0.01. Then the value at this is the value at 0.01. Then y2 is what? This is the y2, means y2 is what? The value at 0.02. This is the value at 0.02. Then value at 0.03, and then value at 0.04 by using Euler's modified method. That is just use the Euler's method and finalize y1, y2, y3 by finding y10, y12, y11, y12, y13, and in this way. So these are some exercise. Euler's modified method. Solve these examples by Euler's modified methods. Okay, by taking h as 0.1. If there is instruction about h, then take h. So here y0 is, that is y0 is 1.5 means y0 is 0, and we have to find the value at 0.2 by taking h as 0.1. Means first find the y1 at, that is the value of y at 0.1, and then value of y at 0.2. Okay. First find the value of y1 by using Euler's method, and just say it is y10, and then find y11, y12, and then find y2 by using same Euler's method. Y2 means the value at 0.2, and y2 say it is y2 0, and then find y2 1, y2 3, y2 2, y2 3, and so on. Okay. So we'll see the last method, RK method, Ranjikutta method, in the next lecture.